Welcome to Astronomy Daily, the podcast that brings you the latest and most exciting updates from the world of space exploration and astronomy. I'm your host, Anna. Today, we'll be covering several intriguing headlines, including the end of a NASA mission, upgrades to the Artemis IV engines, new discoveries by the James Webb Space Telescope, Europe's Ariane 6 launch, and new objects beyond the Kuiper belt, discovered by the Subaru telescope. So sit tight as we dive into these fascinating developments that are pushing the boundaries of our understanding of the cosmos. NASA's NEOWISE mission is coming to an end after an impressive 14-year run that has significantly advanced our understanding of near-Earth objects. Launched initially as the WISE, or Wide Field Infrared Survey Explorer, in 2009, the mission quickly exceeded its scientific objectives by scanning the entire infrared sky. This mission took a pivotal turn in 2013, becoming NEOWISE, Near-Earth Object Wide Field Infrared Survey Explorer, and shifting its focus to asteroid hunting. After developing new techniques to find and characterize near-Earth objects, or NEOs, hidden in vast quantities of its infrared survey data, NEOWISE made 1.45 million infrared measurements of over 44,000 objects in our solar system. In total, it has surveyed more than 3,000 NEOs, discovering 215 of them itself. The spacecraft has provided a huge data reservoir that the scientific community will sift through and learn from for decades. What's particularly exciting about NEOWISE's accomplishments is setting the stage for its successor, the NEO Surveyor, the first purpose-built infrared space telescope specifically dedicated to hunting hazardous near-Earth objects. Scheduled to launch in late 2027, NEO Surveyor aims to find the most difficult-to-detect asteroids and comets that could pose significant threats to Earth. This makes it a critical component of NASA's planetary defense strategy. Interestingly, the approaching solar maximum, the period of highest solar activity during the sun's 11-year cycle, has hastened the end of the NEOWISE mission. Increased solar activity heats Earth's atmosphere, causing it to expand and create more drag on satellites. Since NEOWISE lacks a propulsion system, it can't maintain its orbit under these conditions. Following its last survey on July 31st, the spacecraft will enter hibernation mode on August 8th before gradually falling back to Earth, to eventually burn up in the atmosphere. NASA officials have praised NEOWISE for surpassing all expectations. Joseph Hunt, NEOWISE project manager at NASA's Jet Propulsion Laboratory, lauded the mission for providing vast amounts of data that the science community will use for decades to come. Amy Mainzer, the principal investigator of NEOWISE and NEO Surveyor, emphasized that NEOWISE has been crucial in developing the next-generation infrared space telescope. It's amazing to think how far we've come since the mission's inception, and even more exciting to ponder what lies ahead for planetary defense efforts. With NEOWISE paving the way and the NEO Surveyor gearing up, it's clear that NASA is committed to continuously improving our planetary defense capabilities. The Artemis IV mission will soon launch, and it's bringing some significant upgrades along for the ride. One of the standouts? The modernized RS-25 engines. These engines, originally from the Space Shuttle era, have seen some impressive updates to prepare them for the Artemis missions. This mission in particular will be the last to use these updated engines before NASA switches to newly manufactured RS-25 engines starting with Artemis V. So, what makes these upgraded RS-25 engines special? For one, they now include modern flight computers capable of handling higher temperatures. This is crucial because these engines will be in close proximity to the SLS solid rocket motors, which generate intense heat. The upgraded engines have undergone comprehensive tests, ensuring that they can meet the rigorous demands of the Artemis IV mission. In addition to the high-tech upgrades, the mission will also feature the debut of the advanced Block 1B configuration of the Space Launch System. This configuration includes an exploration upper stage powered by 4 Aerojet Rocketdyne RL-10 engines, a step up from the interim cryogenic propulsion stage used in earlier Artemis missions, which was powered by a single RL-10 engine. The enhancements don't stop there. The new universal stage adapter above the exploration upper stage increases the volume for payloads by 24%, compared to industry standard 5-meter class payload fairings. What does this mean in practical terms? Well, the upgraded SLS Block 1B rocket can now deliver 38 metric tons of payload to cislunar space in a single mission, compared to just 27 metric tons with the Block 1 configuration. For cargo-only missions, the payload capacity increases to a whopping 42 metric tons. All of these advancements make the Artemis IV mission a significant milestone. It not only marks the end of an era with the last use of the updated space shuttle engines, but also heralds a new age of space exploration capability. With more powerful and efficient engines, higher payload capacities, and cutting-edge technology, the Artemis missions are paving the way for even more ambitious space endeavors. Stay tuned, because the launch of Artemis IV is set to be a game-changer in NASA's journey to explore the Moon, Mars, and beyond. The James Webb Space Telescope has made a groundbreaking discovery that has the scientific community buzzing with excitement. The telescope has spotted a potentially habitable exoplanet named LHS 1140b, located 48 light-years away in the constellation Cetus. What makes LHS 1140b especially intriguing is the possibility that it harbors a temperate water ocean, potentially half the size of the Atlantic. Water is a fundamental ingredient for life as we know it, making this discovery particularly significant. Until now, detecting liquid water on distant worlds has been a key milestone scientists have aimed for in the search for extraterrestrial habitability. LHS 1140b could soon be the first exoplanet where we indirectly confirm the presence of liquid water on its surface, according to Charles Cadieux, the lead author of the study that announced the discovery. Revolving around a red dwarf star that's about a fifth the size of our Sun, LHS 1140b sits comfortably in what scientists call the habitable zone, where conditions are just right for liquid water to exist. This zone is often referred to as the Goldilocks zone, neither too hot nor too cold, but just right for life as we know it. Adding to the excitement, Ryan McDonald, a NASA Sagan Fellow, suggests that initial observations with the JWST have even hinted at an atmosphere on LHS 1140b. This is a monumental step forward because it could indicate that the planet has retained a substantial atmosphere rich in nitrogen, much like Earth's. If true, it means LHS 1140b might offer conditions suitable for supporting liquid water and, by extension, life. This discovery is not entirely out of the blue. LHS 1140b has been a subject of interest among planetary scientists for some time. Previous telescopes like Hubble and Spitzer have gathered substantial data on this exoplanet, but they lacked the advanced capabilities of the JWST. What sets the James Webb Space Telescope apart is its power to disentangle complex data, separating planetary signals from those of the star it orbits. Thanks to JWST's keen eye, previous ambiguities about LHS 1140b being a mini Neptune, a type of planet unsuited for liquid water, have been laid to rest. The possibility that LHS 1140b is actually a super-Earth with massive water content is incredibly exciting. To illustrate how unique LHS 1140b is, let's consider its rotation. Similar to how the same side of the Moon always faces Earth, LHS 1140b may also have one side perpetually facing its star, creating stable conditions that could support a liquid ocean on that side. This bullseye ocean scenario, where one hemisphere contains a vast temperate water body, offers a fascinating picture of what life could potentially look like on such an exotic world. While there's still much to learn about LHS 1140b, this early discovery offers a promising lead in the quest to find habitable worlds beyond our own. As we continue to study this remarkable exoplanet, who knows what other cosmic revelations await us in the universe? Stay with us as we move on to our next topic. But remember, this is just the beginning for the James Webb Space Telescope and its mission to reshape our understanding of the cosmos. Europe's space aspirations are taking a giant leap forward with the imminent inaugural launch of Ariane 6, the newest rocket developed by the European Space Agency. This launch isn't just another mission. It's vital for ending what some have termed Europe's launcher crisis, a period marked by the delays and challenges that stymied independent access to space. But what makes Ariane 6 such a significant milestone for the continent? First and foremost, Ariane 6 represents Europe's best answer to the fast-evolving dynamics of the current aerospace industry. With a planned flight rate of 10 to 12 launches per year, Ariane 6 aims to serve both government and commercial clients efficiently. Its versatile design allows for two main configurations: Ariane 62, which is more suited for smaller payloads, and Ariane 64, configured for heavier missions. This adaptability ensures it can cater to a wide range of payload requirements, making it a robust choice for varied missions. One major boost is the strong interest from commercial players. Ariane 6 has already secured an impressive lineup of 30 orders, including 18 launches for Amazon's Project Kuiper satellite constellation. A full order book before the rocket has even flown speaks volumes about the trust placed in this new launch vehicle. However, the celebration is tempered by the reality of the fierce competition Ariane 6 faces. SpaceX has revolutionized the industry with its reusable Falcon 9 rockets, which can be used multiple times, significantly reducing costs. Notably, SpaceX's Starship, which is still in development, proposes to deliver massive payloads at rock-bottom prices per kilogram. Such advancements pose a looming threat to traditional expendable rockets like the Ariane 6. Another challenge is staying operationally independent while balancing collaborations. The European Space Agency and Ariane Group must ensure that Ariane 6 delivers on its promises of cost efficiency and reliability to remain competitive. They have built partnerships with various stakeholders to diversify Ariane 6's capabilities, addressing multiple market segments from heavy lift to medium payloads. One aspect working in Ariane 6's favor is its capabilities tailored for geotransfer orbits and high-energy missions, necessary for tasks such as launching navigation satellites and interplanetary missions. Here, the rocket's sophisticated design, with its enhanced upper stage featuring Vinci engines, provides the required thrust and precision. While critics argue that Ariane 6 might become obsolete in the face of upcoming reusable rockets, it's clear that Europe has positioned Ariane 6 as a crucial player in the space launch market. Balancing between cutting-edge innovations and long-standing reliability, Ariane 6 aims to secure Europe's footing in the increasingly competitive domain of space launches. So, as we watch the Ariane 6 prepare for its first flight, the rocket symbolizes much more than a technological achievement. It represents Europe's resilience and ambition to claim its spot as a global space power. As it lifts off, it carries with it the hopes of meeting new space frontiers and overcoming the rigorous demands of a rapidly changing aerospace landscape. The Subaru telescope has made yet another significant discovery by identifying new objects beyond the previously known boundaries of the Kuiper belt. This region, lying beyond Neptune, is a fascinating part of our solar system filled with icy bodies and small celestial objects. The Subaru telescope's expanded view into this remote area has the potential to transform our understanding of the outer solar system. The Kuiper belt traditionally is thought to end abruptly around 50 astronomical units, AU, from the Sun, setting a distinct boundary for this region. However, recent findings from the Subaru telescope suggest that there may be more beyond this limit. Using the Hypersuprime Cam, a powerful observational tool, researchers have been able to identify objects that hint at a possible extension of the Kuiper belt. One of the major contributors to this discovery, Dr. Fumi Yoshida and his team, utilized an innovative method that layered consecutive images to detect the movement of distant objects. This analysis has led to the identification of 7 new celestial bodies. 2 of these have already had their orbits preliminarily determined, receiving provisional designation from the Minor Planet Center. The implications of this discovery are immense. If these new objects truly reside beyond the 50 AU boundary, it could indicate that our solar system's primordial nebula extended much further than we previously believed. This would not only reshape our understanding of the Kuiper belt, but also offer fresh insights into the formation and evolution of our solar system. Moreover, the collaboration between the Subaru telescope and NASA's New Horizons mission continues to yield impressive results. The New Horizons mission, which famously flew by Pluto in 2015, and another Kuiper belt object, Artemis, in 2019, relies heavily on such contributions to navigate and study these distant regions. In summary, these new findings from the Subaru telescope are not just about adding more objects to a catalog. They're about unveiling the dynamic history and ongoing processes that govern our cosmic neighborhood. As researchers continue to analyze the data and spot more distant objects, our map of the solar system grows more detailed and intriguing. This is just the beginning of what promises to be a deeper exploration into one of the most mysterious regions in our celestial backyard. That's all for today's episode. Thanks for joining me on this cosmic journey. Don't forget to visit our website at astronomydaily.io to listen to all our podcast episodes and check out the latest space news from our continually updating newsfeed. You can also find more space news and stay connected with us by following Astronomy Daily on Facebook, X, and TikTok. Stay curious, keep exploring, and always remember to keep looking up.